Hello students, welcome to Sri Siddheshwar Women's College of Engineering Solapur. Myself Dr. Yogita Gajanan Datar, Assistant Professor in Engineering Mathematics from this college. In the last video lecture, we have seen why the subject mathematics is one of the most important subjects in the course of engineering, and whatever you have learned up to 12th standard or up to first year of diploma is very important to complete this course of engineering mathematics successfully with higher marks. Now we are going to discuss some of the prerequisites for engineering mathematics. In 7th standard, you have seen or you have used expansion formulae. Some of the expansion formulae are square expansion of a plus b, which is given as a square plus 2ab plus b square. Similar one, square expansion of a minus b, which is given as a square minus 2ab plus b square. Next one is cubic expansion of a plus b and cubic expansion of a minus b. All these results are the particular results of one of the most important theorems used in the mathematics, which is called as binomial theorem. The statement of the binomial theorem is a plus b bracket raised to n equal to a raised to n plus nc1 a raised to n minus 1 b plus nc2 a raised to n minus 2 b square plus nc3 a raised to n minus 3 b cube, and so on up to the last term ncn b raised to n. You may observe that if we put n equal to 2 in this theorem, you will get this result, and if you put n equal to 3, you will get this result, and if there is a minus sign in between, then you will get alternately positive and negative terms in the expansion. Here one thing is observable, that the degree of the first term a reduces from n to 0. At the same time, the degree of second term b increases from 0 to n, and this applies to all these four formulae which we are using very frequently in the subject mathematics. So using this general statement of binomial theorem, you can find expansion of a plus b bracket raised to n for any value of n which is a positive integer. So here one more thing is that here the formula for combination is involved. You have learned this concept in 11th standard or in first sem of diploma course. So this is the one of the prerequisites for engineering mathematics. One more interesting thing for in this expansion formulae now we are going to see, and it is given here in a triangle. These formulae just you have seen. Here one important thing is that the coefficients are 1 to 1. In this expansion also 1 to 1. In a plus b bracket cube expansion, the coefficients are 1, 3, 3, 1, and here also 1, 3, 3, 1. Now using binomial theorem you can find the expansion very correctly, but we are having one more shortcut method to decide these coefficients, and it is given by Pascal, the mathematician Pascal, and this shortcut method is nothing but this triangle which is called as Pascal's triangle. So this triangle is very helpful to write the coefficients of the terms in the expansion using binomial theorem. So this is for degree 0, this is for degree 1. You may observe here, if it is a plus b bracket raised to 1, then the expansion is simply a plus b. The coefficients are 1 and 1. This is for degree 2. Here 1 to 1. Here also 1 to 1. And in case of the square expansion or cube expansion or nth power expansion of a minus b, you will get alternately positive and negative terms, but there is no change in this coefficients. So this is for degree 3, and similarly you can get the next row of coefficients for degree 4. Now the interesting thing is how to obtain these coefficients for higher degrees. See, in this triangle, these side elements are simply 1 and 1, and when you add these two, you will get 2. When you add these two, you will get this element. Same for here and same for the next higher degrees terms. So what you have to do, you have to just write 1 1 1 to the two sides of this triangle. You will get the middle elements just by adding in this way. So this is known as a Pascal's triangle, which is very helpful to write the coefficients of the terms using the binomial theorem. So all this is about the expansion formulae. Now the next point is corresponding to this one only, and which is known as factorization formulae. After expansion formulae in 7th standard, you have gone through this concept of factorization formulae. So here exactly reverse process we are doing. Whatever the terms we are given, we have to factorize them. We have to find the factors, means we have to find the terms whose product is nothing but the given term. So the very well known factorization formulae is for a square minus b square, and the factors are a plus b into a minus b. Similarly, we can find the factors of a cube minus b cube. The factors are a minus b into a square plus ab plus b square. And here the first factor is linear factor, which is a minus b, and this is a quadratic factor. Why this is a quadratic factor? Because all the terms here in this second bracket are having total degree 2. And remember, here if this is minus, then here it is plus. And the coefficients of all the terms in this second bracket are 1 1 1. Similar result for a cube plus b cube. The factors are a plus b into a square minus ab plus b square. Whatever the sign is over here, the exactly opposite sign is over here. This applies to this factorization formula also. Now, after expansion and factorization formulae, we have learnt laws of indices in 8th standard. So all these are the laws of indices. Some people call this as rules for indices. So what is an index figure? Index figure is nothing but a raised to m, a raised to n, whatever the product we can write in short form is the indexed figure. If it is 2 into 2 into 2 into 2, we can write this in shortcut way as 2 raised to 4. So this is the indexed figure. So the first rule is for the product or multiplication of two index figures such that their bases are same and the indices may be different. Then in that case, we have to just add the indices to get the final product. In case of division, you have to just write it as a raised to m minus 1. That is, we have to take the difference of the numerator's index and the denominator's index. So it gives us a raised to m minus n within few seconds. Now, the next one, to power of index figure. So in that case, we have to multiply both the indices so as to get the answer. Next, in case of root or surds, if it is square root of a, then you can write a raised to 1 by 2 as an index figure form. If it is mth root of a, then you can write a raised to 1 upon m. Same way, you can have the result for a raised to minus m as 1 upon a raised to m. And if m equal to 1, then you will get 1 upon a equal to a raised to minus 1. Combining these results, we can have this result as a raised to n upon m is equal to a raised to 1 upon m raised to n, and a raised to 1 upon m means mth root of a and all term bracket raised to n. Here you have to remember this one, a raised to 0 is equal to 1. So this result we are using many times while calculating the answers, particularly in case of definite integration. That is, we are writing e raised to 0 as 1. E is a real number and it is raised to 0 gives answer as 1. Now, corresponding to laws of indices, we have learnt laws of logarithm in standard 9. The laws of logarithm are very similar to the laws of indices. Here, the first one is log of xy to the base a. This can be written as log of x to the base a plus log of y to the base a. Means log of the product of two terms is nothing but the addition of their individual logs. The same case for division of two numbers logarithm. Log of division of two numbers is nothing but the difference of log of numerator and log of denominator. And all these laws of logarithm you have learnt in 9th standard and you have used many times during your 12th standard exam and also in first year diploma course. So all these are very helpful to solve the examples in engineering mathematics. Now after this one, these are the particular results for different values of x and y, and you have to by heart these results not only for laws of logarithm but also for expansion formulae, factorization formulae, laws of indices, and the most important thing which you have learned in your primary school, that is the tables from 1 to 30. So all these are the important part of prerequisites of engineering mathematics. But these are the concepts which you have learned up to 10th standard. The next part, the next and most frequently used prerequisites for engineering mathematics is nothing but differentiation and integration. And these two important concepts and their corresponding important results we are going to discuss in next video lecture. Till then, go through all these formulae, all these results, and all the best for your engineering course. Thank you.